We are going to discuss this, how to control this water contamination by using chlorine dioxide technology. I will take only two slime as well as order. Let me spend a couple of minutes before coming to the topic. Morning we had that we are tagged with the environmental unfriendly industry just because we use fibrous raw material and intensive water in the paper making process. Already we are tree plus, but water, many mills they are doing their effort, they are putting their effort. Depending on the grade they make, some mills they are taking water from the after secondary clarifier treatment, and some mills they are taking, like kraft mills, they are taking after primary clarifier. See, what is the difference between raw water as well as effluent? The only difference is biological. So to reduce water consumption, now more and more mills they are going to recycle treated water back to the process. To make paper, we don't need drinkable quality of water. We need a processed water or any water which can help. It should not disturb our machine runnability. It should not increase our chemical consumption. At the same time, it should not give any adverse effect to the final product like brightness and order, etc. So anyone in the room can tell you what is the main sources of these impurities. Mainly it is furnace, which has everything except good fiber. Process chemicals we add to maintain the properties like retention at DSR and starches, etc. Coating chemicals, bleaching effluent, and pulp mill washing, etc. These are the main culprit to make this water dirty, which is going to ETP. So, coming to the topic, I am going to discuss the kraft mills. With those who are working on 100% recycle, they said ZLD, they don't discharge a drop of water. So, what is the advantage and what is the disadvantage of using that water? So, they take processed water to the DAF or some, then to the primary clarifier, and from primary clarifier, the water is taken back to the system. See, primary clarifier has been designed for the physiochemical separation. It will reduce your TSS and suspended solids. It may be TSS, turbidity, or insoluble or inorganic BOD, COD, etc. But it is not going to touch your soluble part like TDS and conductivity, hardness and alkalinity, and soluble BOD and COD. So, if you are going to use this water for paper manufacturing, you have to take care of these three properties. TDS, higher TDS will make your strength chemical ineffective. Starch will get hydrolyzed. It will give foaming. High hardness and alkalinity, it will increase your chemical cost. You have to dose more retention to achieve certain level of retention. And COD. COD will give bad smell and odor like many kraft mills that are struggling. So, now, lot of starch, neutral pH, so perfect breeding ground for the microorganism. So the result of this microorganism, we have slime, algae, and so many bacteria in the system. So just to monitor those parameters, we have chosen three properties: ORP, TBC. I will stick myself to the this microbiological control, because TDS and hardness alkalinity is a different subject. So just for the microorganism, we are monitoring ORP, TBC, and VFA. Like ORP, it is measured in millivolt. I will explain ORP in little detail in next slide. TBC, because number of bacteria will be very high, so we measure as a colony forming unit. So it is CFU. ORP is measured in the millivolt, and volatile fatty acid in ppm. It's organic acid. So just I will explain ORP. What is ORP? You can compare in microbiological terms, you can compare ORP with pH. Like pH tells about the acidity or the basicity of the solution, ORP tells about the molecule. It is in oxidation state or reduction stage. If ORP is high in positive side, it is in oxidation state. It means the organic acid present in the solution, it will oxidize to the adjacent molecule. But in case it is negative, ORP is say -50, -100, then it is in reducing state. Means, so it is the status of solution, collective electron activity of the solution, meant to be in simple form. Like ORP -400 is 4 times more reducing than ORP 100. And we maintain ORP level depending on what grade we make. So, why chlorine dioxide? We have many disinfectants in the like H2O2, ozone. So why we have chosen chlorine dioxide? And chlorine dioxide you cannot transport. It's very explosive. You have to make on site. So still. Chlorine dioxide, it is very selective to the microorganism. It does not get with we have lot of systems. We don't want our disinfectant to go and interfere with the other substance because other chemicals has been added for the different purpose. We want disinfectant to go and do the job. So chlorine dioxide, you can see, it does not react with the most of the alkenes, ethers, organic compounds, starches, organic acids. Everything. Diol is a aliphatic which has double hydroxyl. Like glycol, you can say glycol is a aliphatic diol. Now, second advantage of this chlorine dioxide, it is effective across the pH. See, in our ETP, generally we work at around 7.5 to 7.8 pH. So chlorine dioxide, if we compare with the other disinfectants, after 6.5 or 7, they start getting hydrolyzed. So this is one of the reason to go for chlorine dioxide. Now, we can see here, like we compare with the chlorine and chlorine dioxide. This part of chlorine will be consumed by pH adjustment and approximately 50 to 60% will be consumed by organics. So, effective amount available for the disinfection is hardly 30%. But in this case of chlorine dioxide, it is around 80 to 90%. Oxidation strength is less than 1, so it is very less corrosive if compared with the ozone. Ozone oxidizes everything that comes on the way, so it is very less corrosive. Capacity is very high, it exchanges 5 electrons, so consumption will be very less. I am rushing to the side because I think the watch is running much faster than expected. This is excellent pre-treatment. Like if we have sometime our water becomes black, if we put into stagnant condition due to iron, so it can hydrolyze the iron, it can hydrolyze the sulfide. This helps in reducing this odor because mostly odor is due to H2S or mercaptan. Again, microbiology, they make a biofilm. The biofilm is so, for chlorine dioxide easily penetrates the biofilm, but if you compare with the other disinfectants, they are not able to control, they just reflected to the biofilm and this microorganism, they remains very coolly inside that biofilm. So this is additional advantage of using this chlorine dioxide. To summarize with, chlorine dioxide destroys biofilm, does not produce dangerous byproducts like THM, trihalomethane, HHA5. Sorry. HHA5 is a group of 5 acids: monochloroacetic acid, monobromoacetic acid, dichloroacetic acid, dibromoacetic and trichloroacetic acid, and bromates. It has higher oxidation capacity, we have seen there, not affected by the pH. So, we have seen a lot of advantage using chlorine dioxide, but if we cannot transport, it's very difficult to use, So, now there are generators, they are available in the market, and you can use to produce on-site. This is the reaction. Chloride with acid, it produces around chlorine dioxide. Dose is around 3 to 4 ppm. So accordingly 4 ppm NaCl will be produced. This will increase your hardness, TDS. So TDS increase is very, very minimal. This we can skip. This is the typical chlorine dioxide generator. It's a flooded type reactor. So even there is flow variation, efficiency will not drop. It's a fluid IoT solution, so you can control remotely. It is available in different ranges, up to 1 kg, then 3 kg, 5 kg. So whatever paper industry, craft mills up to 400 tons, they can go with around 1 to 3 kg maximum. These are the case studies. Now chlorine dioxide is being used as odor control in all part of the India. We have the difference in north, south, east and west, so you can refer those difference. And this is one of the paper mill. So what we are doing, our target is to maintain microbiological anaerobic count up to 10 to the power 3 CFU and BFA less than 500 in paper. And we are testing at our lab, mill lab and external agencies like IIT, Bellur, CIPRI and so to conclude with, chlorine dioxide can be used as a just to control, and all the mills, even they have different opinion in order, but machine runnability has improved like anything. So all the mills they accepted that in lower GSM, 100 to 120 GSM, machine runnability has been improved, and around 8 to 10% of production increase. So that's it. Thank you very much.
Thank you, Tapan. I must thank all